coming up with our list of 25 projects to look at for digital archaeology, I think probably it was Fabrizio that said, where is everybody from? And what countries are everybody from? And Shoei, you were not only one of the only architects with projects that came to mind from Asia, but very curiously, for all of the technology in Japan and all of the manufacturing, it seemed like it was very late that Japanese architects got interested in digital technology, and that you were one of the first by decades to get interested in digital technology. So just asking you the same question I've asked everyone, why were you among your colleagues so unusually drawn to the computer, and for what reasons? And for also what reasons are you not interested in the computer?
Oh. I was familiar with the computer when I was studying economics. That's what I told you before, and it was 1960s, 50 years ago. And I have no idea what the computer is going to be at the time. And I was majoring in fine and applied arts at the Wittenberg University in Springfield, Ohio in 1962. And it was at the time I was baptized by Miss at the restaurant Four Seasons in a Seagram building. And I spent all holidays and vacations in New York and wandering in MoMA, and I was longing, and I really loved to visit the Knoll showroom, Knoll International Showroom. Do you know the furniture maker Knoll? They produced all the furniture designed by architects like Mies or Le Corbusier, so that I was so influenced by modern architects. And the reason why I came to the States was that when I was working in Ginza in Tokyo, I was struck by interior design of Charlotte Perriand, who was assistant designer of Le Corbusier. I found it much later. And I hated, in those days, architects. You know why? All the architects said always, oh, this is regulations, this is the budget, so limited. That's what they always said. So there's no freedom or liberty to design. So design has no limit, I thought, at the time. It was a misunderstanding. And I wanted to be an interior designer, first of all. And recently I found Mies was working together with Lily, a lady, German lady, before he became a teacher of the Bauhaus, and he taught together with a lady in Bauhaus. And interior design is a kind of foundation of architecture. That's what I thought. And I love the chairs and mise design for the Tugendhat House and the Barcelona Pavilion and chaise lounge of Le Corbusier for the Savoy. So my background is city economist with a doubt that is unbelievable, but I found Lux soap sold millions by wrapping gold printed paper, wrapping paper, because of just the paper. And so it was a design. And it's like a magic or the, how to call that, trick, or if it's the same soap in gold wrapping paper, looks more, how to call that, valuable for probably for as a gift or something like that. Then I was very much interested in design, but I hated Lux. And I hated also the, how to call that, the for the Hitler architect designed the Spear?
Albert Speer?
Spear? Or the lighting in there in the night. Spear? I don't know that. What's that?
Lighting in the night.
Lighting in the night. And Hitler was a very good advertiser and agitate the people so that the design is able to, frankly, it's kind of, how to call that, make people comfortable or feel a little rich or something like that. And the computer, I have been using this kind of computer to see the future demand in the market.
Oh, no, I remember in Fukuoka,
I told you that.
you showed us this economic curve,
Demand.
and the computer was drawing a curve to show.
Yeah, demand and the supply curve. And the meeting point is the selling amount of the
Yep.
volume of the cars. And I found in 20 years or 30 years in the history, sometimes it doesn't fit out of these lines.
Mm-hmm.
And I tried to find out why, because a human do the rational judgment, rational.
Mm-hmm.
If it's expensive, you wouldn't buy. If it's cheap, you will buy. But even if it's expensive, with a white tire, it sells. Or the less carton on the rear window, it looks more deluxe. That's why they sold more than other cheaper cars. And I hated that. I'm still hating architects.
But so, for you, the computer was a tool for prediction in economics,
Right.
and
Econometrics.
and you believe very much, because especially the two projects in the show are public projects for taxpayers,
Right.
that you want them to be optimum economically.
Yeah.
Could you talk a little bit about?
It was the first time for me to design public buildings. I was teaching in Rotterdam, and until then I had been designing my clients were more or less friends or brothers or sisters or my parents or my clients, so that I didn't mind at all. But once I got the public design, I felt so depressed because of the heavy burden on my shoulders, paying money for the people, and so I'm also the one of the taxpayer, so I hate to spend money. You understand that?
Long term, it's not so.
But the monument may be different, and if you're rich enough, you can spend any money as much as you want. Okay, then public design is very valuable and must last long, and easy maintenance, and also when I was designing a wooden structure, it was the first time for me to design a wooden structure, and I asked a professor who helped Alexander, architects from the States, design a wooden school, high school in Japan, and Dr. Matsui, who wrote the book. Oh, it's not here, but light elasticity,
Photoelasticity.
Photoelasticity was the way of proving the safety of the wooden structure without calculations. And all the carpenters in Japan never had the ability to prove the safety, which is required by the government. So that it was me who proves the safety of the wooden structure by calculation and experiments, owing to Dr. Matsui's experiments. And also the marrow globe, which was introduced from Germany to Japan, and the marrow globe system has got computer analysis from the beginning.
And that's the system of ball joints of connecting
Right,
frame.
Right. Nobody used it in the States. Philip Johnson made a chapel, cathedral.
Yeah, the Crystal Cathedral. Yeah.
With a three-dimensional truss,
Yeah.
painted in white. Also, IMP designed the World Convention Center
Okay.
in New York or somewhere.
Javits? Yeah. Yeah, Javits Center used the same system?
Three-dimensional truss
Huh.
system. No, but the German system was introduced at that time, and it was the good material, good joint, the best joint, I thought, in order to use for the wood. The wood I used was young cedar wood, which are not useful for other purposes, because it was first reason they have to thinning the density of the mountain in the forest. They cut the young cedar wood, 20 years or 30 years, which is thin. Then at the time, Canada and United States were pushing Japan to import the heavy timber, which are very inexpensive, so that all the forestry town had a very hard time, and that's why when I was assigned to make a gymnasium in wood, only solution was to use the thin, short timbers connected together, and they replace, easy to replace when the wood is burned or cracked. Then mirror system, I studied 1984, and 5 years experience with the flat, deep, same depth,
Uniform depth or
uniform
constant
deep,
depth?
standards, three-dimensional structure. But in that case, we have to choose this big, this big, all different forces, depending on the where to support. Even the roof on the top, we have to have a snow load, but wooden structure is so light, and when wind blows like a typhoon, the roof lift up, minus tensile. So compression and tensile both we have to resist, so that I told you that I'm not educated to become an architect. I had no idea, or I knew nothing about the structure. But through the process, getting the permission from the government, I came to Tacoma Dome to see it, how to stop fire or something like that. Then I learned at the committee of the Ministry of Construction of the government with the Dr. Matsui from Waseda University, who helped the what's the name? Alexander. Christopher Alexander.
Yeah. But so for you, the manufacturing of the ball connection and the
Mass production at the time.
and that mass production would allow
Same angle, same length.
right, but the technology was there to make all of those elements vary. No?
Right.
And so, for you, the model that's in the show that has the moire effect and the photoelastic picture, which is on the poster for the exhibition and also at the entry, those two things were pointing you in the direction of making each of those elements varied.
Right.
So how did the projects develop for you? Once you had that image, the desire to
Yeah.
achieve that image.
First of all, the selection of wood, 6,000 or 7,000 wood, different sizes, was my job.
Mhm.
This one is good for this on the roof, or this for the lower part,
Mhm.
this for the bracing. And anyway, I was doing that, selecting the wood, and it was a kind of analogy of a community.
But it was,
So that the various members,
yeah.
and I didn't know why, but after the computer simulation,
Mhm.
all people at the factories said, oh, we need this big or this small.
But before that
So
ever
that-
happened, you had drawn a plan with columns
Right,
that were not on a grid.
right.
And also you had an intuition about not having a uniform
Right.
element. And that was all done in the physical model, or that was all done in drawings?
Drawings. You're talking about how did it happen?
Mm-hmm.
Okay. In Toyama, it's northern part of Japan. It has got heavy snow, 3 meter deep, which is almost 900 kilogram, 1 ton per square meter. Very heavy. In the long span, when we have deep, like a crown hole, we have to have much deeper thickness of the 3D truss. And at the same time, I had the image, and I was very much impressed by the Isozagi's Guggenheim, Barcelona Olympic Stadium, Montjuic Hill, on the Montjuic Hill. The proposal was so striking and attractive for me to do something which is wavy. And suddenly I found out the thickness of the 3-dimensional truss can be different according to the span. So I studied section. If wider the span, we have a deeper depth. And when we have a cantilever, the support has to have got a higher, deeper depth. So that I can imagine, I had the image of having this kind of shape. The space itself has got requirement to be used as a gymnasium or the exhibition hall. It was for the exposition.
Mm-hmm.
So that I started, maybe this is the flat 3D-dimensional truss, but it deforms when we have 900 kilogram heavy weight of snow load, and we'll have to reduce to 0 the deformation, deformation or distortion, which is
Yeah, deformation.
deformation. And we studied many kinds of patterns. And we finally got next picture. Then that one. It was the last. It was so stiff and rigid, never deformed, but looks so wavy and soft. It looks opposite. If it's straight, you think it's stiff. But if you have got this kind of a section of the roof, you feel, oh, it's unsafe, it's not safe. But nature is that way. And it becomes homogeneous inside. All the members are the same members, but different in dimensions. The angles are all different. The steel grove joint, we have got 8 tubes to accept in different angles. Even the bottom and the bracing fall, and it happens on the top at the same time. But computer is very helpful. It was done very quickly.
And so, if this is optimized for structure,
Right.
and it's optimized for the function in the plan,
Yes, right.
and the computer was really for you the optimizing tool
Yeah.
to make that the most economical it could be.
Yeah.
But then you have an ambition that the result is not just the perfect form, but also a form that evokes.
But still,
You said it's
there,
so-
there were many more options
Mhm.
in forms. I decided the one I like.
Okay, that's what I wondered.
Because I relocate the supports here and there. A meter here, 2 meters here, something like that. I can relocate all the location of the supports so that the shape has been changed. Then, in that case, I had a level line on the Z, or X, Y, and Z the coordinates.
Yep.
Keep the level, and 2 by 3, 2 above the level, 3 below the level, so that it has got this kind of shape. But we could change in many ways. Whatever you like. So that this was the design I did, and I kept horizontal lines because I was so primitive. And later, I forget about the level.
You mean in, say, Odawara?
Odawara, yes. And it was much more complex.
Yeah, and the plan of also Odawara is more complex.
And swimming pool, and the kendo, and judo, and basketball. And the first period of the construction and second period of the construction, we will have a connection in between the two. And we were a little bit advanced and paying attention to the lighting and the acoustic effect and the air conditioning and many other things. And the shape itself, I pay attention to the location of the building, which is along the river, looking at the Mount Fuji on north, and the mountains around, so that I was thinking of responding to the surrounded environment, the context. So it has got too many parameters to put in, but we could have done it.
Now, because we have, before we open it up to questions, just about 10 minutes, I know you want to show some other projects than what are in the exhibition. I think it would be interesting to do that.
Maybe yes. But how many minutes have I got left?
9
I believe you're
minutes.
all tired listening to
Well, I want to
the
leave time
audience.
for them to ask you questions like the
Okay.
others, so.
Oh, this was the one. What?
Albert, can you go back? Yeah.
Oh. You see that the context of the location responding to the housing near on south. So we have a slant pitched roof, lower roof for daylight to come in, and keep a little bit of space between the buildings and the housing. And there's a river bank on the right-hand side, on the east. Okay. Then, I explained to you already. Okay. Then it's so complicated. I don't know. I didn't understand heterogeneous or the homogeneous, but how to call it? Heterogeneous or not?
The structure is for sure heterogeneous.
Yeah, responding.
Yep.
Okay. Okay, then let's go to next.
Next what? What do you want to have next?
I wanted to show you the natural phenomenon
Okay.
and the relationship between the computer analysis and the photoelasticity
Okay.
and the model with the Moire patterns.
Sure.
Okay.
Okay, so Albert, can you pull up maybe first the photoelasticity image?
This is my hand. This is the model in there.
Yeah.
And this is the shape I designed, I like. And on the top, we have got a little bit steeper for water drainage. And this is the model up there, and it's showing the patterns, water patterns. This is three-dimensional. It's the surface of the model interference each other and make this pattern. The many more patterns have got more strength or the resist the load or force. And this is the shadow of the daylight, the sun, which is coming in parallel light. So this is the shadow of the pattern of the model. And this is identical to the photoelasticity. Can you show us that next, maybe? Oh, this. I already explained you. Okay, go ahead. Next and next. This is the process. The engineering was. I didn't do this. I asked the people who helped me. We collaborated and back and forth, and it was just like a dialogue between the machine and me. I change, and the computer respond. And then I respond and return the alteration of the location of the supports. So we go back and forth. Yes, that's right. Go ahead. It's a study, but very enjoyable game.
But I think what's...
And okay, this is the last Well, how about the next one? With the patterns, it becomes even homogeneous in these patterns. But when we have color, let's see. Go back on the next one. Don't you have one? Oh, then forget. This is the computer analysis and showing the bending force,
Yeah, the loads and stress.
loads and stress. But it's now, the stress is even, then no color. Looks flat, right? But people would think this is safer because it has got a different depth. Then we got equal, how to call that, support. And I should have told you that analogy of the community, the three-dimensional roof is like a community, hand by hand, holding hands. And if somebody is sick and miss, the other members help you. So it won't break, it wouldn't collapse. Three-dimensional is a solid shell. So I wonder why nobody follows my idea using a three-dimensional truss structure. This is Odawara, and much more complicated.
Okay, well, I think it's time to open it up for questions.
Okay.
I would ask you what role abstraction plays for you, like the photographs of the moire, the photoelasticity, the wireframe analysis. It seems like you were working with the computer, with photography, with different ways of verifying the design. At what point did you build the wooden model that's in Gallery 2, in the room with the 4 models? Was that after the design, or was that during the design?
4 models.
The wood model. The wood model of Toyama. Was that built at the end, or was that built in...
At the beginning.
At the beginning.
I mean, right after I decided. And it's not the study model, it's a presentation.
Presentation model, okay, that's
Yes.
what I wondered.
It's a made of plastic.
Was it
not
made of
wood.
plastic? I thought it was wood.
Right. No, plastic.
Oh, you just always tell me it's
It
wood.
was easy to glue. I'm sorry.
And that was done with the chart of all the angles and the lengths. Somebody had to cut all of those lengths accurately,
Right.
measuring it, right?
Right. Computer does this.
Yeah. Okay, well, great. I think it's been 45 minutes, so let's open it up and see if there's some questions.
Okay, go ahead.
I'm very fascinated by the moire pattern. When you made the moire model with the wire, did you know it would have a moire effect?
No, it was a discovery.
So that's interesting. And do you think because...
I was taking pictures of the model in the garden, and when I found this moire pattern on the floor as a shadow, oh, it's divine.
So do you think that the moire pattern,
Yes.
which is like the visualization of the stress,
Yes, right.
do you think it's like a kind of is it an optical trick, or do you think there's something deeper, a deeper connection?
Dr. Matsui experimented the wooden structure for Christopher Alexander, and he told me this is the way how the stress, which is invisible, make it visible with the photoelasticity, with the hologram, right?
Mm-hmm.
So I knew that though, but there's no connection between ours and because we made a model first, and I discovered, oh, what is this? And this is the same, looks almost same as the Dr. Matsui's photoelasticity. So that there's a coincidence. We found it.
But when you say a similarity between his photoelasticity experiments in general, or he had already done a photoelasticity analysis of your project?
Much later.
Much later he did it of the project.
Yeah, because I asked him to experiment, and I found the same.
Mm-hmm.
So, natural phenomena, when we say, we're enjoying, but we always have a natural disaster in Japan, but we enjoy also natural beauty. Peter said that anti-natural. He likes city boy. And he says only 2 weeks in springtime he can enjoy flowers, and only 2 weeks in the autumn, the following leaves.
Yeah.
But we have a little bit longer, spring and time and autumn in Japan.
I suspect that your sense of phenomenology is not just the springtime and the flowers.
No.
And so I'd love to have you explain why you use the term, in what way, what are you thinking, why do you call your work phenomenology? Phenomenology.
Oh, I have to start why I met Stephen Hall. Stephen Hall,
Yes.
as architect from.
We know him.
No.
He's a friend of the CCA, kind of.
West side of the continent, Seattle, Washington.
Ah,
He was from Seattle, right?
Sure.
And he came to Japan and Fukuoka to design an apartment. And he just happened to see my natural phenomenon art museum. I designed it because I've been thinking the natural beauty we can use for the art, or if you have the aesthetics in your mind, you see beauty all the time in any sequence in the garden, even in the wintertime or summertime. And I proposed the gas company to build a phenomenal art museum, just because they were making gas flame art with spraying the metallic liquid, so the color changes. You know that.
I remember.
Or if you use the copper or anything,
Yep.
you change the color of the flame. And they were very much fond of the kind of things to show the people.
Mhm.
So I told them, why not to build a Saab Gas, that's the name of the company, Phenomenal Art Museum. And we imported many from Exploratorium in San Francisco, or the many artists from the States, and Tom Shannon with magnetic things, many artwork were exhibited, so that I've been devoting everything to the natural phenomena art.
But I've never told you this before. When Stephen Hole and Bernard Schumi told me that you were coming to teach at Columbia and asked if I would assist you with the studio, Stephen said, you have to see his work. It's all about phenomenology. And without any insult to you, I said, oh my God. I thought this sounds like torture. And I said, I don't know about this. But so then Stephen showed me your work, which the Phenomenological Art Museum, I remember it had robotic floors in it, so it was full of robots, and it had flaming gas,
Yes.
and it had
A tornado?
it had a tornado, and I thought, this guy's going to be great. And likewise, when you said you were doing structural optimization, I thought, oh no. And then I saw that you were doing the first three-dimensionally topological roof. And so I think what Phyllis is asking is there's a dissonance between you saying you love nature, but meanwhile you have flaming robots. So it's, I mean, I think it's very interesting. You go through very abstract processes to achieve these effects, which I think is very different than Stephen Hall, who really who likes natural light and things like that.
We call each other phenomenologists.
Yeah.
Both of us like the lighting, daylight.
Yeah,
coming
he
in.
doesn't have robots and topological roofs.
But you know the definition of economic
No?
was economy definition is least how do you call that, effort, maximum profit economy. And this day economy, or I would say economics, which I learned at school, doesn't work these days. The interest is so low, but nobody spends money. It's against our study. I mean, the Keynes or the economics. But I'm an economist, a pragmatist, and hating architects.
Okay, so are there, maybe two more questions?
Just to follow up quickly on that, but I mean, actually, the beauty of this is to see the profit is in the phenomenology, actually, right? I mean, there's I think a lot of the interest of this work and the new direction, I mean, the direction which you were doing with this, but now seems to be a new direction with people using digital software is to reap the benefits of the phenomenology that's created by the tools, right? And that you know, a simple roof or simple changes to a roof can give you a moire effect, right? I think that this can be seen as a profit too, or isn't one of the, well, sorry, can't this be a good thing? I mean, for a designer, right?
Good point. Aesthetics, ethics, at the same time. Ethics. And ethics is not economical. Aesthetics is not economical at all. It has nothing to do with it. But nature is beautiful and profitable. We can enjoy the nature. Do you oppose it?
Well, no, that's an argument no one's going to not, everybody has to love nature. Only a few people. Peter Eisenman will say that.
Yeah, that's what I said.
But otherwise, that's, but I think the point is that it can't just be economics, that it actually, you're finding an opportunity instead of saying, we're going to make everything uniform.
For 20th century.
Yeah, that even the space frames at the time that were uniform, they were sizing the wall thickness of every single member to save. So it was economical too.
Yes, yes.
But you found a way, which I think is most interesting, a visual way to find other opportunities that gave you a different result.
Right.
I don't think that it's, I don't think there was only one result.
No, there are many options.
Yeah.
Lots of options, and we have to judge which one you like best and which is more comfortable, which is more beautiful, which lasts long, which that is the durability or the maintenance cost for the taxpayers. Oh, I'm paying tax also. Nobody pays me tax. But spending money of the people, and I will be responsible in many ways. I'm still responsible for the wooden building, wooden gymnasium. I promised to the government I will be responsible all in my life. So they permitted to build illegal buildings.
Well, somebody's always got to do the first one.
Yeah, maybe the last.
Okay, well, I think there's time for one more question, if there's one more. Okay, otherwise, I'd like to thank everybody. This has been 3 hours of really
Yeah, quite
interesting
long.
discussion. So, thanks very much, Greg.